Hey everyone, and welcome. Today, we're diving into what I like to call the fundamental grammar of the digital world: data types and data structures. To really understand the story data's trying to tell you, you first have to learn the language it speaks. So let's get into it. So, let's start with a big question. Is all data created equal? I mean, think about it. If you have a customer's name and the amount they spend, can you really treat both of those pieces of information the same way? The short answer is absolutely not, and understanding why is pretty much everything.
Here's the game plan for this explainer. First, we're going to talk about why this is so critical to get right from the start. Then we'll break down the three main ways to classify data: by its content, its relationship with time, and its format. And finally, we'll see how it all comes together in the wild world of big data.
Before we jump into all the different types and labels, let's just pause and talk about the stakes here. Getting this stuff right isn't just some nerdy technical detail. It is the absolute foundation of any good analysis. Every single step you take after this depends on it. And this quote just hits the nail on the head. You can have the most powerful computers, the smartest people, but if you're trying to, say, calculate the average of a list of cities, your results are going to be completely meaningless. It's not just bad math, it's what leads to really bad business decisions. And the real-world consequences? They're serious. We're talking about businesses launching products based on flawed ideas, making financial forecasts that are way off base, or just completely missing a huge opportunity that a competitor spots. Getting the data type right from the very beginning helps prevent all of this. Okay, so let's get into our first and maybe most fundamental way to classify data. What is the actual content telling us? Is it describing a quality or is it measuring a quantity? This slide does a great job of splitting the entire world of data in two. On one side, you've got qualitative data. This is all about description, things like colors, names, categories. On the other side, you've got quantitative data, which is all about the numbers. It's anything you can count or measure. So let's start with the simplest type of qualitative data: nominal. The key thing to remember here is that there's no order to it. Is blue better or bigger than red? Is Ford ranked higher than Toyota? Of course not. They're just labels. They're names, which is right there in the word nominal. But the other type of qualitative data is ordinal. And here, order is everything. Excellent is definitely better than good, which is better than poor. But, and this is the crucial part, can you mathematically prove that the gap between good and excellent is the exact same as the gap between poor and good? Not really. There's a clear ranking, but the intervals between them aren't uniform. Now let's hop over to the quantitative side, which also splits into two main types. First up is discrete data. This is anything you can count in whole numbers. Think about the number of people in a room. You can't have 2.5 people, right? Then you have continuous data, which can take on any value within a range and can be measured with crazy precision. Here is a perfect, super simple example of discrete data. You can count the cars. 1, 2, 3 cars. You're never, ever going to have 3.14 cars in the parking lot. The values are distinct, separate, whole numbers. Now, contrast that with this. The time it takes to run a lap isn't counted in neat little chunks. It can be measured with incredible precision, down to tiny, tiny fractions of a second. Between any 2 points in time, there are basically an infinite number of other possible measurements. That's the heart of continuous data. All right, so we've covered what the data contains. The next way we can slice it is by asking when it was collected. And this is a total game changer for analysis, because it forces us to ask, are we looking at a single moment in time, like a snapshot? Or are we watching a story unfold over time, like a movie? I just love this analogy. Cross-sectional data is like taking one big group photo at a party. You capture information about a lot of different people, but only at that one specific instant. Time series data is like putting a camera on just one person and recording them for the whole night. You're tracking the changes for that single person over a period of time. And here's what time series data looks like in the real world. We're looking at just one thing: company revenue, and we're watching how it changes at regular intervals, quarter by quarter. This is exactly the kind of data you need to spot trends, notice patterns, and try to forecast what's coming next. So what if you could have both? What if you could film a time-lapse video of the entire crowd at the party? Well, that's panel data. It tracks multiple subjects over time. which makes it one of the richest, most powerful types of data you can get your hands on, because you can analyze both individual changes and the dynamics of the group as a whole. Okay, our final dimension for classifying data is all about the format. How is it all organized and stored? Is it in a nice, tidy box that's easy to work with, or is it more like a jumbled mess that we have to sort through first? This right here is structured data, and it should look really familiar to you. If you've ever used a spreadsheet or seen a database, you know what this is. It's all organized into clean rows and columns. Every column has a defined purpose, and every row follows the same rules. It's by far the easiest kind of data to search and analyze. And then you have everything else. This is unstructured data. It has no predefined model, no organization. Think about all the text in an email, a photo you post online, a video file, a song. There's a ton of valuable information locked inside, but it's so much harder to get to because it doesn't fit into those neat little rows and columns. So we've looked at data through the lens of content, time, and structure. Now let's bring it all home and see how all these concepts crash together in the modern world to create this huge phenomenon we call big data. Now, here's the thing that people get wrong all the time. Big data doesn't just mean a lot of data. It means the data is so large, coming in so fast, and is so complex, especially with its mix of types, that your traditional tools, like a simple spreadsheet, just can't handle it. They basically just freeze up. And this is famously defined by the 3 V's. You've got volume, which is just the mind-boggling scale of it all. Velocity is the speed. Think about data streaming from social media in real time. And then there's variety, which is exactly what we've been talking about, this huge mix of structured, unstructured, qualitative, and quantitative data all getting generated at the same time. And that really brings us to the key takeaway. Whether you're a data scientist, a business analyst, or frankly just anyone trying to make sense of the world today, this isn't just an academic exercise. Being able to look at a piece of information and know what it is, well, that's the first and most critical step to unlocking its real value. So, the next time you see a spreadsheet or read a report, or even just scroll through your social media feed, ask yourself this question. By understanding these building blocks, you've really started on the path to becoming data literate. The only question left is, what are you going to build with it?